take 2 because I positioned the paper so that you couldn't see it. So here we go. F of x equals cosine of 3x. F prime of pi over 9. That looks like a disaster. Well, let's see what's going to happen. Okay, so this is the original function. We want the derivative. Okay, derivative of cosine, negative sine. Should be a piece of cake. Negative sine, 3x. Wait a second, chain rule, times 3. So if you like, the derivative is negative 3 sine 3x. Oh, great, I got the derivative. Wonderful. All right, so now I need to plug in pi over 9. So I'm going to plug in pi over 9 here, and I'm going to get negative 3 times sine. So I'm going to do this quickly. 3 times pi over 9 is pi over 3. Okay? So now you can take your time on this, however you want to do it. This is 60 degrees. So sine of 60 degrees is the square root of 3 over 2. So this is the square root of 3 over 2, just like that. And now we multiply, and we get negative 3 root 3 over 2. And we cross our fingers and hope it's one of the answers, and it's E. Boom, we're done. Okay. 9. Here we go. Okay, you can see that, yeah. Graph the piecewise linear function f is shown in the figure above. If g of x is, well, looks like a accumulation function, which of the following values is the greatest? I haven't done this yet, so let's figure it out. Okay, so this is what I see. Negative 2 to something. Okay, fair enough. So if it's negative 2 to negative 2, we can immediately see g of negative 2 is 0. I'm just plugging in negative 2 there. That's 0 because we don't pick anything up left or right. Okay. So now g of 0, well, let's see. Okay, so we pick up all of this. That's a lot to get picked up. So right now I'm just going to say, well, that's going to be positive because we picked up a lot. G of 1, we pick up even more. So I'm going to go ahead and say that's plus plus. That's even bigger. Now g of 2, oh, wait a second. Now we start losing stuff. So that's a little bit smaller than this. So I'm just going to call it a plus. Keep in mind, we're trying to figure out which is the absolute greatest. So right now that's our candidate. It's not B, it's not C, it's not E. Maybe it's D. Let's check A. So now I go to A and I'm like, okay, so I'm going to plug in negative 3 here, right? Okay, so from negative 2 to negative 3, I'm going backwards. Remember, when we go backwards, it ends up being negative. So we actually lose this much. So this would be a negative number, meaning, oh, D totally has to be the greatest. We're done. Okay. 10, blah, blah, blah. Oh, this is annoying. All right. Graph of the function f is shown above, blah, blah, blah. It's too big. Yeah, it's too big. I'm just going to skip it. It physically doesn't fit on the page. Neither does this one, but this one's so important that I'm going to talk about it. Okay. Graph of function f is shown above. Which of the following could be the graph of its derivative? Okay, so this is what you want to think. Here's the function. I want to know which one could possibly be the derivative. So I'm going to kind of chop it up. I'm going to say, all right, well, let's see. From here to here, the function, this is not the derivative, this is the function. The function is increasing. That means the derivative totally has to be positive. So from here to here, the derivative, whatever it is, it's got to be positive. So I look and I'm like, well, wait a second. If this is the derivative, that's not positive, that's negative. It's definitely not D. It's negative all the time over here. Yeah, it's positive there. It starts positive, starts positive. Okay, so maybe it's one of these things. What else do we know? We know that from, let's see, from here to here, zoop, this is the function. It is whoop, decreasing, which means from here to here, our derivative has to be negative. Let's check. Oh, wait a second. From here to here, nope, that's positive. Can't possibly be A. It's negative here. That checks out. Yeah, that more or less checks out. All right, let's see what else. So it's either B or C. So I'm going to look at this little interval right here now, and I'm going to say, okay, so it's decreasing. So the derivative has to be negative right here. From here to here, the derivative has to be negative. I look down at C, and I'm like, wait a second. No, it's positive here. Got to be B. B is the only one left. Okay. Here we go. All right, this is just figuring out a derivative. Okay. So here's our original function. We want to know what the derivative is. Okay, so e to anything, the derivative of it, f prime of x, is going to just be e to that thing. But then remember, it's a chain rule situation. So now we need to say to ourselves, times the derivative of whatever is up here. All this garbage is what I sometimes say. And that's the derivative of 2 over x. So what does that become? Well, that's e to the 2 over x. That's no problem. The derivative of 2 over x. Okay, so I'm going to come up here and I'm going to rewrite that. So 2 over x is the same thing as 2x to the negative 1. Now I want the derivative of that. So whoop, the negative comes down, negative 2, and it's x to the negative 2, just like that. So I say to myself, oh, okay. So I multiply it by the derivative, which is this here. It's negative 2x to the negative 2, just like that. And then we cross our fingers and we're like, oh, wait a second. I thought that was the answer. It's none of those things. Sometimes you have to rewrite it. So it's e to the 2 over x. This gets rewritten as negative 2 over x squared. Please be one of our answers. Boom, it is. It's D. Great, wonderful. D. Terrific. Okay, 13. We talked about this one in class, but real quick. Okay, here's our function. We wanted the derivative. We want to know the derivative of what happens when we plug in the natural log of x. So I'm literally going to plug in the natural log of x before I do anything. Natural log of x squared plus 2 times the natural log of x. Okay, so here we go. Now we need the derivative of this entire thing, okay? This is kind of a chain rule situation. So whoop, the 2 comes down, becomes 2, natural log of x, times the derivative of the inside. You have to know that the derivative of the natural log of x is 1 over x. You just have to know that. Now over here, plus 2 to natural log of x, so it's plus 2 times the derivative of the natural log of x, which is 1 over x, so this becomes 2 over x. Okay, so now I'm looking at this and I'm like, well, can I rewrite this at all? Sure, why not? 2 natural log of x over x plus 2 over x. Is that any of our answers? This is the same thing as A. Pause it if you want. If you don't believe me, go ahead, have a look at A. Okay, there it is, done, and I'm 5 minutes in. Good. I hope I don't have to stop here. Let me look. The polynomial function f has selected values of its second derivative, f double prime, given in the table above. Which of the following statements has to be true? I'm actually going to stop here because I have to think about this for a second.